Hello and welcome back to our course. So in this session we learn about Boolean indexing of Numpy arrays. So what does it mean? So let's assume we have a Numpy array with many elements and we want to check element-wise if the element meets a certain condition. So for example, we want to check if each element is greater than 5 or not. And with Numpy we can do this in a vectorized fashion. So we do not need to write for loops or if, elif and else statements. So let's start the code. Let's import Numpy. And then we create a Numpy array from 1 to 10. And then we check element-wise. So we have A, if A is greater than 5. So we check for each element here if the element is greater than 5. And what Numpy returns us, it returns a Numpy array with Boolean objects. So here for the first element, so 1 is not greater than 5, it gives us a false. 2 is not greater than 5, false, and yeah, you can see here, starting from 6, we get a true. So Numpy returned us a Boolean array, or an array with Boolean objects. And I called this Boolean array mask1, so we see later what we can do with it. Then, second, we check if each element is less than 8. And then we also get back a Boolean array. So you can see only the last 3 elements of our array does not fulfill the condition and yeah, gives us a false. And we can also make it more complicated, so we can have an AND statement or an AND keyword here. We can check which element fulfills both conditions, so it's greater than 5 and less than 8. So I would assume that the elements 6 and 7, so only 2 elements fulfill both conditions. So we have false, 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 and 2 times true, okay. And we can also take the OR operator, so we check whether at least one condition is met, so at least the element is either greater than 5 or either less than 8. Yeah, and this holds true for all elements, so all elements at least fulfill one condition. So now what if we want the opposite of, let's say, our mask3? So the opposite array where we have, yeah, for each element the opposite Boolean value. And there we have to use the tilde symbol. So this means not, or the opposite of this expression here. So let's see what we get. So let's check again. So we took here the opposite of mask3. So the opposite of false is true, false, true, false, true. And yeah, in the end, so we saw here mask3 gives us 2 truths at element 6 and 7. And here we get truths and only 2 false at yeah, the elements 6 and 7. And what we cannot do, we cannot say, instead of having the tilde symbol, we cannot not say not. So not does not work in a vectorized fashion. And it gives us here the value error. So the truth value of an array with more than one element is ambiguous. So not does not work here in this case. So we have to take here the tilde symbol. Alright, so far we created a new ND array with the Boolean values, which shows us whether the elements fulfill the condition or not. And yeah, what if we want to filter out the elements which fulfill the condition? So let's say here a greater 5, so we want to filter out all elements which are greater than 5, so 6, 7, 8, 9, 10. And we can do this by Boolean indexing. So we take a and then in spare brackets we take the condition a greater 5. And a greater 5 is a Boolean ND array. Let's see what happens. So now Numpy returns us an array or a slice of array a where the condition a greater than 5 is fulfilled. So instead of writing here in spare brackets our condition, we can just put in our mask1, for example. The condition of mask1 is a greater 5. So we already did this here. So we should get the same result. So now we want to slice a for our mask2. So mask2, what is mask2 doing? The condition of mask2 is all elements less than 8. Let's see. So we get all elements until 7. And mask3 should give us 6 and 7. We already had that, yes. Mask4 should give us all elements. So all elements either fulfill condition 1 or condition 2. And mask 5 should return us the opposite of mask 3. So all elements, but not elements 6 and 7. I can see here, so 6 and 7 are missing. Alright, so this is it for Boolean indexing, and in the next session we will learn about how to create random numbers with Numpy. See you there!